In this lesson, we'll talk about solving equations, particularly equations that have fractional coefficients and proportions. We'll apply our understanding of solving linear equations with integer coefficients, what we did at the very beginning of the class, to solving linear equations with fractional coefficients, and then we'll also solve proportions that simplify to linear equations. So before we start, and this concept is also going to apply to the next lesson, which is solving rational equations. If we look at these equations, w over 3 equals 5 over 3, without picking up your pencil, think of what w has to be. Remember, when you're solving an equation, you're finding the value that makes the equation true. In this case, w would have to be 5, and that's because if you substitute it in, 5 over 3 equals 5 over 3, which is true. Moving to the equation on the right, we have w plus 3 over 3 equals 7 over 3. What does w have to be? W has to be 4 because 4 plus 3 over 3 equals 7 over 3, and 7 over 3 equals 7 over 3, which would make it true. So the concept to take away from this are a couple things. When we have fractions, we can apply the concepts that we know with solving an equation. Also, notice that when the denominators are the same, you can kind of let them go and focus on solving the numerator. We could have solved the second one by taking w plus 3 equals 7, subtracting 3 from both sides, and getting w equals 4. This concept of common denominators and then taking a look at the numerators is going to become very helpful when we're dealing with fractions, whether it's solving a linear equation with fractional coefficients or solving a rational equation dealing with denominators. So example 1, solve for x. So we have negative 2/5 x minus 4/3 equals 4/3 x minus 4. Since we have a lot of fractions, I'm going to go ahead and make everything a fraction by putting the 4 over 1. Now I've got all fractions. The next step, using what we know, is we want our denominators to be the same so we can let them go and take a look at what we have. So between 5, 3, 3, and 1, the least common denominator is 15. Okay, let me take a side note. I do these problems different than the way Alex does. Either way is okay. This is just another method that might be helpful to you. So if our least common denominator is 15, we take a look at each fraction and determine what we need to multiply the denominator by to get to 15, and then we multiply the numerator by the same. So for our first fraction, we need to multiply 5 by 3 to get to 15, which means we multiply the numerator by 3. For the second fraction, we need to multiply the denominator by 5, so we multiply the numerator by 5. Same thing. And then for the last one, we'll multiply by 15 over 15. So one thing I'm going to do as well is notice how x is just kind of hanging off to the side here. I'm going to put it with the numerator. That's where it can actually go. I'm also going to put any negative signs with the numerator. So this becomes negative 6x over 15 plus negative 20 over 15 equal to 20x over 15 plus negative 60 over 15. So now that the denominators are the same, we can let them go, just like the principle we talked about, and solve the remaining equation. So this is negative 6x plus 20 equals 20x plus negative 60. Oh, this should be a negative 20. Look, we have a linear equation. We know how to solve these problems. So the problems don't necessarily get harder, they just get a little bit longer to reduce down to a linear equation or a quadratic equation. So we get our x's to one side, so I'm going to move over the 6x. I'm also going to move over the 60. And so we get 40 is equal to 26x. Divide both sides by 26. And so we get x is equal to 40 over 26, which reduces to, if you divide them both by 2, 20 over 13. And the way that I got 20 over 13 was divide 40 by 2 and divide 26 by 2. Next, solve for x. 8x plus 1 over 2 equals 2x plus 9 over 6 plus 10. Again, I'm going to put the 10 over 1, so I'm just dealing with all fractions. Our least common denominator between 2, 6, and 1 is 6. So you look, what do I have to multiply 2 by to get to 6? If you have to multiply 2 by 3, we're going to multiply the numerator by 3 as well. And put parentheses here to remind yourself that the 3 is going to go to both the 8x and to the 1. The fraction 2x plus 9 over 6 already has the common denominator, so now we're looking at 10 over 1. we need to multiply the denominator by 6, which means we multiply the numerator by 6. So in this case, we have 3 times 8x plus 1 over 6 equals 2x plus 9 over 6 plus 60 over 6. We let go of our denominator, and we would have, distributing this 3, 24x plus 3 equal 2x plus 9 plus 60. Again, we have a linear equation that we know how to solve. So we get our x's together and our numbers together. So we'll subtract 2x, subtract 3, and we're left with 22x is equal to 9 plus 60 minus 3 is 66. We divide both sides by 22, and we get x equals 3. Okay, you can also check your work for these problems by plugging in the value you get for the variable into the original equation to make sure you get a true statement. Solving proportions. So proportions happen when we have a fraction equal to another fraction. You can use the denominator, get common denominators like we did before, and then let go of the numerator, or you can cross multiply. Example 1, solve for x. X minus 2 over 8 equals 3 over 4. So in this case, I'm just going to show cross multiplication because we've already shown common denominators. So what you do is you cross upper numerator to lower denominator, and you're multiplying the entire numerator by the entire denominator. So this means 4 times x minus 2, then we put the equal sign, and then you go the other way. 3 times 8, okay? So now we have 4x minus 8 equals 24, another linear equation. So we add 8 to both sides, and then we divide by 4 to get x equals 8. And again, you can check this by plugging it into the original. Next, solve for x. So we have some negative signs in here. We cross multiply. So this is negative 6 times x plus 3. The most common error with these problems is to not distribute the negative 6 to the x and the 3. This is equal to negative 15 times x. And then we distribute, and then use what you know about solving linear equations. So this becomes negative 18 is equal to negative 9x. Divide both sides by negative 9. And we come up with x is equal to 2. Right, if you have any questions, feel free to reach out to me.